Alright, good evening everyone. This PowerPoint presentation is based on lipids and it was put together by yours truly. Now, in this presentation I would seek to give a general description as to what lipids are. Then I would deal with some of the major classifications of lipids. Following this, I would go into the structure and the function of each of these various classes of lipids. Now, these are some of the areas where I got my information from. These books are very good. I would recommend that you read them for yourself. And apart from these books, I also found information in some very useful PowerPoint presentations as well as some videos that I came across. Okay, first of all, a general description as to what lipids are. Now, this classification is given to a large class of organic molecules which show tremendous variability. Some characteristics of lipids include solubility in organic solvents as well as poor solubility in water. Because they are soluble in organic solvents, they are known as hydrophobic, and their poor solubility in water, well, both basically say the same thing. Now, lipids may either exist by themselves or they may be conjugated. Example, glycolipids. This consists of a carbohydrate and a lipid. And functions of lipid may include energy storage, cell signaling both within a cell and between different cells, and protection. Now, there are many other functions of lipids, but we would go into more detail with them as we come across them. Now, that basically covers the general description of lipids. Now, what we would do now is classify these lipids, and this would help to make it a little simpler to understand. The first group is known as fatty acids, and this consists of eicosanoids, triacylglycerides, waxes, glycerophospholipids, and sphingolipids. The second main class of lipids are what we call isoprenols. These include terpenes, steroids, and lipid vitamins. So we basically finished with the general description and the major classifications of lipids. Now we would go into the structure and function of each of these classes. First, we will look at fatty acids. Now, these have a hydrophobic hydrocarbon chain and a terminal hydrophilic carboxyl group. Now, when you find a molecule having both a hydrophobic nature as well as a hydrophilic nature, we call that molecule an amphipathic substance. Now, this amphipathic nature of fatty acids has tremendous transport consequences. Now, remember we stated that the hydrocarbon chain is hydrophobic. This would mean that very long chain fatty acids, since they will have a lot of hydrocarbons, those fatty acids will be hydrophobic in nature, and as a result of this, they won't be able to transport in the aqueous bloodstream easily. Because of this, you would find these long chain fatty acids associated either in the form of cholesterol esters, phospholipids, or triacylglycerides within lipoproteins. Or if these fatty acids are free, well, not really free because will be joined to albumin. In fact, 90% of the circulating fatty acids would be in the form of lipoproteins, and remaining would be in albumin. Now, fatty acids are usually described based on their number of carbons, which is usually an even number, and the number of double bonds. And these fatty acids may either be saturated, that means there are no double bonds, monosaturated means there is a single double bond, or polyunsaturated. Now, this table shows some of the common fatty acids that you may have come across. At the top of the table we see formic acid that has one carbon, acetic acid, also known as ethanoic acid, CH3COOH. These are very small chain fatty acids, and generally you don't really consider them, well, we don't usually go into much detail in their fatty acid property. But as you increase the carbon chain length, you see that fatty acids with 4 to 10 carbons are found in significant quantities in milk. And if I'm not mistaken, this has something to do with their ease of absorption that would facilitate babies, etc. And as the carbon chain length increases. They are known as long chain fatty acids. And here we see, just briefly mention that some of them are precursors to prostaglandins, some are essential fatty acids. All of those things you will go into little more detail a bit later on. But for now, let's just look at the fatty acid components. Now, nomenclature. Fatty acids may be counted either from their alpha N or the omega N. Now, the alpha N is that part of the molecule that contains the carboxyl group, the COOH group, and the omega N is the N that contains the methyl group, that's the CH3 group. And we'll see how different omega fatty acids and so on have various functions. Very important. Now, this table basically shows some of the very important long chain fatty acids. Here we come across stearic acid. We see 18:0. What this means is that it has 18 carbons if we were to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's 18, and the 0 means that there are no double bonds. Well, this double bond at the top within the carboxyl group, sorry, we're not considering that. We're speaking about that is the functional group. We're not speaking about that. We're talking about in the actual chain. And here we see another fatty acid, linoleic acid, and we see 18 too. That means it has 18 carbons and 2 double bonds apart from the carboxyl group. And in brackets we see 9,12. That basically shows the position of the fatty acids from the alpha N. That's the N with the carboxyl group. So it's after the 9th carbon and after the 12th carbon that you would find the double bond. Now, linoleic acid is not to be confused with linolenic acid. Linoleic acid has 2 double bonds and linolenic acid has 3 double bonds. And you would see, if you count from the omega N now, you would see that linolenic acid is a 1, 2, 3, is an omega 3 fatty acid, and linoleic acid is a 1, 2, 3, 4, 5, 6, an omega 6 fatty acid. And these have very important consequences. Now, because membrane lipids typically contain long chain fatty acids, the presence of double bonds in some of them help to maintain the fluid nature of those lipids. And here we see 2 long chain fatty acids, and here we see that we have a trans isomer and a cis isomer. And the cis isomer would have hydrogens on the same side at the double bond. And you see that the cis isomer has a unique shape, and we call this a kinked molecule. And this kinking in the chain would help with the fluidity of those lipids. But on the other hand, these trans fatty acids would pack tightly, and these are not healthy. And here we see a little note that trans fatty acids are produced by fermentation in the rumen of dairy animals, and as such they can be obtained from dairy products. They also can be made from the hydrogenation of vegetable oils, and trans fatty acids are very unhealthy. Okay, now we come to essential fatty acids. And if you remember earlier, we were speaking about omega 6 linoleic acid and omega 3 linolenic acid. And these are so-called essential fatty acids because they cannot be synthesized in the body. And they are also precursors for very important polyunsaturated fatty acids, including prostaglandins, thromboxanes, leukotrienes. All of these stuff we will come across a little later. Just remember that essential fatty acids are so named because they cannot be synthesized in the body, as well as the fact that they are used to produce other polyunsaturated fatty acids. Now, due to time constraints and the size of this presentation, I won't be going into detail concerning the sources and importance of omega 3 and omega 6 fatty acids. I will leave you to do some reading on those. Now, fatty acids are not popularly found alone. Rather, they are usually in ester or amide linkages. Now here we have an ester linkage. Anytime a carboxylic acid reacts with an alcohol in this way, an ester is formed. You see the carboxylic acid here, alcohol, OH group, And this is a condensation reaction, meaning that a water molecule is given off and is ester form. So fatty acids are usually in ester form or in amide linkage. And here we see these are not fatty acids, but I'm just showing you the amide linkage between a carboxyl group and an amino group. And once again, a condensation reaction is occurring where a water molecule is given off. Good. So we basically dealt with fatty acids there. Okay. So now what we'll move on to are a group of molecules known as poissonoids.